In this segment, we're looking at symmetry of graphs. There are three basic types of symmetry we want to identify: x-axis, y-axis, and origin, and I've got each of those graphed here. By symmetry to the x-axis, really what we're talking about is being able to fold over the x-axis and having the picture align with itself. You probably did this sort of thing in grade school when you made Valentine hearts. You folded the paper and just drew the one side so you had a perfectly symmetric heart, or maybe you did it for a butterfly, that sort of thing. So symmetry is usually involving a fold. And what it also means in this particular case is that if I have a point xy here, it's going to have a matching point when I fold it across. It's still going to be x, but it's going to be negative y this time. Right? Y-axis symmetry is similar, except it means we could fold along the y-axis and have our picture line up. So my point xy is going to have a matching point. It's the same y horizontal level, but we're over at negative x instead. Origin symmetry is a little bit tougher to see. I've got this function graphed here, and it represents origin symmetry. Maybe you can see it that if you fold down over the x and then back over the y-axis, you would actually have a matching picture. Another way of looking at this is if you've printed this out, if you turn your paper upside down, which would represent a 180-degree rotation, it's going to look the same as the original picture. So you can think about origin symmetry either way. Here, if I have a point xy, then it was going to have a matching point. Well, it's going to be back, so it's going to be a negative x, and it's going to be down, so it's going to be a negative y. Sometimes it's hard visually to determine which these are because the graphs can be a little bit deceptive. So we're going to look for some algebraic tests as well. We want to make sure we know those. To test for x-axis symmetry, what happened here? If I replace the y by the negative y, I get the same equation. Doesn't matter which one, I'd still get the same x answer. For y-axis symmetry, if I replace a negative x and x, I get the same thing. It doesn't matter if I use negative x or x, I still get the same y value. And for the origin symmetry, I can replace both x and y with their negatives, simplify, and I'll still have the original equation. Let's take a look at a couple examples. Okay, we want to determine if they're symmetric to these different axes. Well, you can graph these in your calculators, certainly, and I've got the pictures here. Just so you know, the absolute value function can be found on your calculator as well. To find that, let me pull up my calculator. We go to your y equals, okay, and we want to put this expression in here. I go to the math button, and I go over to the number column, and the first thing is ABS, that's absolute value. So ABS, and then my x plus 5, okay, and then I hit my graph, and I get the picture that we've got listed there. Okay, well, it's pretty obvious just looking at this that there's no symmetry. Whether I fold over the x-axis, there's absolutely nothing down there. Fold over the y-axis, well, it's not going to line up. And if I turn it upside down, it's going to be a totally different picture. So there's no symmetry. The next one, x squared plus 4 equals 3y. If I graph that, it looks like this, and it kind of looks like, yeah, I think these points should match up. That means xy gets paired with negative xy. So I want to verify algebraically, if I put a negative x into this equation, will I get the same as the original one? Well, when you square a negative, yeah, it's the same as x squared, so I do get the original. It confirms y-axis symmetry. Okay, y equals 2 over x. If I graph it, I get this picture, and if I kind of double fold or I turn it upside down, it kind of looks the same, right? So that means xy would get paired with negative x and negative y. Let's confirm it algebraically. Replace both your x and y with their negatives, and then simplify. Well, if I put them in and I multiply both sides by -1, I get my positive here, I get my positive here. Yeah, it's the same function. That's confirmed.